So once again, split it into two separate integrals. How are we going to deal with this 6e to the power of 4x minus 2 business? How are we going to deal with that? Okay, let me ask you a reverse question then. How do we deal with this one? Let's deal with the other one first. We can worry about the e to the power of something x. So if I give you 4x to the power of 2, or negative 4x to the power of 2, and I try and integrate that, what's that going to become?
X, 3.
Good. Raise the power by 1, divide by that new power. Yeah, plus e, obviously, yeah, good will. Make sense?
Yeah.
All right, fine. Now let's come back to this one. Okay.
That one,
How would you do it?
the opposite of derive e to the power of some
Yeah.
x basically. So it's divided by what's being
Yep.
by the power. But
Derivative of the power.
Do something though.
You do. The easiest way of thinking about it then,
You integrate that part? Or?
yes, good. So you differentiate that part and divide by that new power.
Oh, okay.
So divide by all those. Easiest way to think about it though, if you're kind of stuck, always think what's making this thing awkward, right? If you have a function buried within another function, exactly what we had for question 1, exactly what we've got here, e to the power of a function, not worried about the 6 just constant, it's nice, friendly. But e to the power of a function, you let u equal that function and make a substitution, okay? So if we let u equal that 4x minus 2, when I differentiate, what do I get? 4. Which means that dx must be equal to a quarter du. Yeah? So if I go back and just sort of do my integration then, so just do integral, pull the 6 out, that becomes e to the power of u. Obviously I need to make a substitution for dx as well, which I've done. So I'm just going to pull the 4 out times by du. That make sense? Right. So what's the integral of e to the power of u with respect to u? It's the easy one.
E
To the power of u. Good. And obviously 6 over 4 can cancel to 3 over 2. Okay? Where u was just my 4x minus 2. Okay? So actually the whole thing becomes, once I've fiddled with all of this, the whole thing is going to become 3 over 2 e to the power of 4x minus 2 minus 4/3 x cubed plus c. Okay, so let's go through this one. So question something D, I think it's 10D or something. So we've got a diagram which shows a curve, y equals f of x, whereby f of x is equal to this function here, and I've written on the board. So you can see here that you've kind of got this curve and I've sketched it. And basically I'm looking at the shaded region between 0 and pi by 6, okay? So I need to find the area of that shaded region. That's basically my task. So if I want to find the area underneath the curve, between a curve and an x-axis, what do I use?
Integration.
Yes, integration. So in other words, I need to try and integrate this thing, okay? I need to try and integrate 3 sine of 3x divided by cos of 3x plus 6 with respect to x. What are the limits of this integration?
0.
Pi by 6.
Yeah.
Yeah? So left limit, right limit, okay? So this is what I need to calculate. Now, this doesn't look nice, does it? It looks a bit awkward. So, because it's an integral of two things divided by each other, what should I always check first? Yeah, it goes.
F divided by f to the right.
Other way around, yeah. That's fine. So I need to check this. Always check this, because if you can check this first, your life is going to be easy if this works out, okay? If it doesn't work out, then that's fine. We just use other techniques, for example, substitution or something like that. But okay, let's check this. So I'm proposing that my original function, in fact, let me write it down here on the right-hand side. My original function is cosine of 3x plus 6. Okay, that's my original function on the denominator. I need to make sure that the derivative of this looks something like this. So let's check it. If I give you f of x is equal to this, what's the derivative of cosine of 3x plus 6?
Be minus sine 3x.
Good. Negative sine, so cosine goes to negative sine of 3x. What are you forgetting?
3.
Good.
Yeah. Oh yeah, 3.
Yeah, so just remember chain rule, differentiate the outside function, cosine becomes negative sine. Differentiate the inside function, 3x becomes 3. Okay, obviously the plus 6, just a constant, differentiated, goes 0. Okay, so have a look. Is this the same as this?
Apart from the minus sign, it's pretty much the same.
Pretty much, yeah, I'll take it. It's very, very close, apart from the negative sign. I can rectify that. I need a negative there. I can't just stick a negative in where I like. So I'll divide by out here. Okay, negative, negative, positive, nothing's changed. Yeah? But now I have this situation over here. Okay? So in other words, I can say that this thing should be the negative of the natural log, so I'm looking at the right-hand side now, the natural log of my denominator. So the natural log of cosine of 3x plus 6. And also plus c. Make sense? Okay, now obviously at this stage I can now evaluate my limits. So put my square brackets around it and 0 and pi by 6. Okay, so let's go back, let's stick in pi by 6 first of all. So natural log, or negative natural log of cosine of 3 times by pi by 6, that's going to be pi by 2 plus 6. And then minus, I'll put all that in a bracket, minus, another bracket, natural log, negative natural log, of cosine of 0, which is just 1, plus 6, that's going to be 7. Does that make sense? Okay, now obviously cosine of pi by 2 is going to be 0, so actually if I simplify this slightly, it's going to become negative natural log of 6 plus natural log of 7. Well, if I subtract two logarithms with the same base, just using log laws, that's the same as the natural log of 7/6. Okay, that's going to be the final answer. Now, if you wanted to approximate that, I think, Chun, can you quickly approximate that for me?
0.15.
0.15. Okay, so the area is about 0.15. If you want it exact, it's natural log of 7/6. Now this question was actually on an exam 2 years ago. Okay, so this was part of an exam question 2 years ago. So I gave you a function, this was the function, asked you to differentiate it, integrate it because I wanted to find the area. This is how you do it. So are there any questions here? No? Okay. I think at this stage, if you're feeling a little bit like, oh, I would never have got that, don't worry about it. Just sit back, enjoy the ride. Right? Well, I don't mean that, obviously. Just sort of make sure every step makes sense. Don't worry about whether you can do it now because that will come with practice.